All right, hello everyone. So today we'll be working on some linear algebra. So we've got two matrices, A and B, that are two 3x3 matrices, and we're given the determinant of A equals 4 and the determinant of B equals 3. Find the determinant of the product of two matrices. The first matrix is 1/2 times A to the minus 3 times 5 times B transpose all squared. Okay, now we're going to be using to find this these quantities is using these properties that we have about determinants. So the first property says that if you take the determinant of a product of two matrices, it's equal to the determinant of each matrix multiplied out. If you take the determinant of a constant times a matrix A, it's equal to the number of rows or columns in the matrix n. So in this case, like k to the n times the determinant of A. The determinant of the transpose matrix is the same as the determinant of the matrix A, and determinant of the inverse of a matrix is equal to 1 over the determinant of A as long as the determinant of A does not equal 0. So that's what we'll be using. So let's go ahead and get started. Let me just copy here, and I'm going to copy and paste. Let's do that right here. All right, so let's go ahead and get started. The first thing I see is you have a product of two matrices here and then here. So I can break this up as the determinant of 1/2 A to the minus 3 times the determinant of 5 times B transpose all squared. Okay. Right, so we have two matrices that are multiplied, so we can split it up as such using that first rule. And the next thing I see is that I have constants in front of my matrices here. So if I'm going to take a determinant of these, I can go ahead and pull the constants out in a way, we can think of it that way, and raise them to the number of rows and columns. In this case, it was 3. So 1/2 to the third, the determinant of A to the minus 3. And in our case over here, it's going to be times 5 to the third, the determinant of B transpose all squared. All right, so then how do I deal with the determinant of A to the minus 3? Well, A to the minus 3 is like saying A to the minus 1 to the third power, okay? And what you can do with that, so let me just write this along this way, down vertically, 1/2 A to the third. This would be like saying determinant of A to the minus 1 times determinant times A to the minus 1 times A to the minus 1, excuse me, let me say that again. A to the minus 1 times A to the minus 1 times A to the minus 1. So because it's 3 times, that's why we're doing it. So what you can do is you have a matrix raised to a exponent. You can go ahead and write it out that many number of times, okay? And over here, we have the same idea with a 5 cubed determinant of BT squared. That's like saying the determinant of B transpose times the determinant of B transpose here. And I'll just write that down here just for continuity's sake. And what can I do with that? Well, I can split this up as a product of 3 determinants. This is expanding on that the first rule again. I know it says 2, but it works with any number of matrices that you're multiplying. So if you take the determinant of 3 matrices that are you multiplied, it's equal to the product of each matrix you multiplied. Okay, so it doesn't matter what the size is. And I'm going to go ahead and do the same thing for this one. Determinant of B transpose times B transpose is the determinant of B transpose times the determinant of B transpose. And all of this right here, we know that determinant of A inverse is equal to 1 over the determinant of A. And this would be written out 3 times. This would be equal to saying 1 over the determinant of A to the third power times 5 cubed. And the determinant of B transpose and is equal to just B by that rule we had earlier. and this would equal determinant of b all squared. Now, I am writing this out and being real careful here, but you know, you have a liberty if you feel that you're competent to, you know, skip a couple steps here in terms of the way I'm writing out the notation, really. Yeah, if you felt like it, you can go to here directly, but at first I would just stick to this drawn out method here. All right, and then I'm just going to plug my numbers in. I was given what the determinant of a was, and the problem that was 4. So this would be 1 over 4 to the third, and 5 to the third, and then the determinant of b, I believe, was just 3. Okay, and there we go. And you basically would just compute this out. Yeah, the last step is just to put in the determinants of a and b individually. And this would be 1/8 times 1/64 times 125 times 9, and yeah, whatever that comes out to be here. I think this would be 512, and then 125 times 9. Let's see here. 1125. Okay, and that would be it right there. I hope this helps. Thank you for your time.